thing to pick up the audio.
Yeah.
Okay. Can you verbalize stuff today?
Yeah, I'm working on the homework right now.
Okay.
Although I don't have a lot, so it's going to be still maybe 40 minutes.
Okay. Well, we can go as long as you want.
Alright. Alright, so actually that's a bigger problem. I'm going to do another one.
Okay. You're verbalizing everything, right? You didn't send me anything?
Yeah, I'm going to attempt to verbalize everything.
Okay.
Alright, I have this one. Alright, so a principal of $200 is deposited in an account that pays 4.2% interest compounded yearly. Write and graph the exponential equation.
Okay. Now, let me ask you something. Have they covered just yearly compounding, or have they also covered greater more often than yearly, or continuous compounding?
Yearly.
Just yearly at this point? You haven't had all three?
Yeah, just yearly.
Okay. There's one general equation for yearly. Is this one. Where A sub 0 is the starting amount, A is the amount sometime after that, R is the interest rate, and T is how many years. Since it's compounded yearly, we're going to let T be in years. So we get A equals 200 times 1 plus, you have to convert that percentage to a decimal.
Okay.
Always. And they said how long a period of time? Or they just said write the equation. So,
Right, the exponential equation.
okay, so here's the equation. If I simplify what's inside the parentheses, I get 1.042 to the t power. So there's the equation that applies. And now if we want to graph that, notice that that's just an exponential equation. In other words, if I said graph y equals 2 to the x, it would look like this. Right? They all look like that. If I said y equals 5 to the x, it's going to look a lot like this. It just might be scrunched up and go up a little quicker. So exponential equations all look like this. Well, this one is not 2 or 5, but 1.042 to the t. Whether it's t or x doesn't really matter. It's going to look the same. And this 200 is merely a vertical stretch factor, right? In other words, think about your transformations where you have vertical stretch, horizontal stretch, things like that. Do you remember those? You've been through those or not?
Yeah, we've been through a little bit.
Okay. So it's going to basically have this same shape. There's the exponential function. But the fact that it's vertically stretched by 200 probably means that it's going to go up quicker like that. Okay? But if I drew just the curve, you'd have a hard time telling me what it is, because all of these exponential functions tend to go through the same point, which is 0, 1. Only in this case, it's 0, 200. So the red curve because it's 200 times the black curve, really is going to look something like this. In other words, this would be 200, this would be 1. Because they all, in other words, the key thing to remember with these is that any number raised to the 0th power is 1. So when t is 0, this whole thing is 200, which makes sense, right? You deposited $200 in the account. At the end of 0 years, it better be still worth $200. It hasn't earned any interest yet, but it hadn't gone away, so it's still worth 200. Okay, so there's your function. The red is the graph. What else you got?
Sounds good. Alright, the next one I have is,
excuse me.
So, you buy a used car for $7,000.
Hold on 1 second. 1 second. Sorry. I haven't figured out how to sneeze and listen at the same time. All right. Start again. Start again.
You buy a used car for $7,000.
Okay.
The car depreciates at a rate of 6% per year.
Depreciate means gets less?
Yeah.
Okay.
And so we need to write and graph the exponential equation again.
Okay. Always start from this. Since this is the only one you've had, there are actually 3 of these depending on how often you compound. In other words, if you were to compound every month, it's actually a different equation, slightly. And if you were to compound continuously, it's a different equation.
Yeah.
And in actuality, nature is usually compounding continuously. If you talk about how bacteria grow in a petri dish, it's continuous compounding. Or if you talk about how a population of rabbits, you release 10 rabbits into the wild, how fast they're going to grow, that's continuous compounding. The only thing that's ever compounded on a yearly basis is stuff that man makes up, like bank accounts, car depreciation. Car depreciation actually compounds continuously. They're just simplifying it for you by saying that it drops by 6% per year.
Okay.
And I want to know the car that does that. I mean, the very first thing my father taught me when I was a kid was that new cars depreciate by 1/3 every year. That's 33%.
Yeah.
So it's a little different in this day and age because cars are built a little bit better. So you might actually find a used car that only depreciated at 6%. So the value of that car, the A, is going to be equal to its starting value. And this time the R is merely negative. So it's minus 0.06 to the T. And that gives you the following. There's your equation.
Yeah.
And if I graph it, it's still exponential. It's just 0.94. Now, when you have numbers that are less than, well, let's talk about this for a minute. Let's talk about these 2 equations right here. 2 to the x and y equals 1/2 to the x. Y equal 2 to the x looks like that, just like all the others.
Yeah.
Because when you take powers of 2, each higher power gets bigger, right? 2 squared is 4, 2 cubed is 8, 2 to the 4th power is 16. So it's always going to go from lower left up. But when you take numbers between 0 and 1 and you exponentiate them, Well, it actually looks like this instead.
Yeah.
In other words, the entire difference between my red curve and my black curve is based on the fact that this number here is greater than 1, and this number here is between 0 and 1.
Yeah.
Well, in this problem here, we're looking at a number that is less than 1. So it's not going to follow the black curve. It's going to follow the red curve.
Yeah.
What's the y-intercept? Where's it going to be?
The y-intercept is going to be on the right.
Hold on. Jeez, hold on. I'm not sure what happened. It's Windows 10. I blame everything on Windows 10.
Yeah.
So given that that's the equation, a equals 7,000 times 0.94 to the t. This is the t-axis. This is the a. What's this point right here? When t is 0, what is a?
Wait, doesn't t never reach 0?
Well, it's from you're right. Well, no, that's not actually true. T does reach 0 at the very beginning.
Oh, okay.
In other words, when you buy the car, it's worth 7,000, right?
Yeah.
And there's no depreciation that's happened because t is 0. That's the moment you buy the car. So the point, though, is any number to the 0th power is what?
0.
No.
1. It's 1.
1. So what is this y-intercept? 0, comma what?
1. No. Yeah, 1 is it.
You're missing the 7,000. In other words, this part of the function goes to 1.
Yeah.
But we're multiplying it by 7,000. So that point is 7,000.
Yeah.
When you buy the car, it's worth $7,000. And as you own it, in other words, as t grows, the car gets less and less valuable. Eventually, as t goes to infinity, the car is going to be worthless, goes to 0. Never quite gets there, but t never gets to infinity either. So, but that's the thing you want to understand, is any number to the 0 power is equal to 1. So what's this equal to? Yep. Even though most people have a hard time believing that, it's the truth. 0 to the 0th power is 1. Okay? What else?
Well, I have one more of those.
Okay?
Well, they're not even like, okay, so it's how much must you deposit in an account that pays 6% interest compound yearly to have a balance of 1,000 after 8 years?
Okay. I always recommend with math that almost no matter what the problem is, you start out with the general formula.
Yeah.
This is the general formula. Always start out with that. Okay? Now, in this case, they're giving us this amount, 1,000. They're giving us this amount minus plus 0.6, sorry, plus 0.06, and they're giving us this amount. So we have to solve for that amount there. Okay? And remember that as long as you only have one variable, you can always solve an equation. So I just got to get it down to one variable. So the A is 1,000. That's what it's going to be worth at the end of 8 years. What it started, I'm not sure. That's what we're solving for. But it's growing at 6%. So this is 1.06, and t is to the 8th. So a sub 0 equals 1,000 divided by 1.06 to the 8th power, and you can get that number off your calculator.
Okay. Well, I don't have my calculator with me at the
moment. Okay. It's probably going to be in the neighborhood of $500.
Okay.
Just because I'm kind of used to 6% growth. Usually doubles in 8 years, not quite maybe. So maybe the answer will be close to $600, but it's easy enough to get on a calculator once you have that.
Yeah.
All right.
I have one more question and I'm done.
Okay.
So, manatees are going extinct at a rate of 5% per year. 10 years from now, there will be 2,884 manatees. How many are there currently?
Okay, tell me how to do this problem. This problem is exactly the same as the last problem.
Yeah.
Only it's decay instead of growth.
Yeah.
And you either have one of those two things. You either have growth, like a bank account growing, or you have decay, like a car depreciating, or manatees going extinct. Their numbers are decreasing by 5% every year. So what's the general formula?
Is it I know what it is. I just
Okay. A equals what?
Parentheses 1.
No, remember the first thing is your starting amount. A sub 0 times what?
Yeah. 1 minus
R,
and then parentheses 2.
Right. There's your general. Okay. Yeah. Now fill in everything we know. What's that A going to be?
That A is going to be 10. No, 2,884.
The A sub 0 is what we're solving for.
Yeah.
What's the rest of it?
1 minus 10.
No, the T is the years.
Oh, so it's 1 minus negative 5, or 1 plus 5.
It's minus, it's decay.
Okay.
And that's the difference. You either have growth or decay, or the only thing in between is nothing at all, no change.
Yeah.
In this case, you have decay, but it's very important that you figure out whether it's growth or decay, because it makes a difference whether it's 1 minus R or 1 plus R. So what goes into parentheses?
In the parentheses would be...
What's 1 minus 5%?
That's 4%.
No?
No?
What's a... 1 is 100%. It is a little confusing, but the way to really do it is to always convert that to a decimal first. So I got this. That converts to that. And now that turns into 0.95.
Yeah.
So A sub 0, the starting amount, ends up being equal to the ending amount divided by 0.95 to the 10th power.
Okay.
Now when you take 0.95 to the 10th power, it keeps getting smaller.
Okay.
Let's talk about that. If I take 0.9 squared, it's 0.81. It got smaller, right?
Yeah.
If I take 0.9 cubed, it's 0.729, smaller again. Well, when I take 0.95 to the 10th power, it gets really small. I mean, I don't know. I don't have my calculator to do that, but it's going to make the original amount be bigger than the ending amount, which we would certainly expect, right? I mean, we've got the manatees going extinct. We don't have them multiplying.
Yeah.
So if there's 284 at the end of 10 years, there must have been a lot more than that to start with.
Yeah.
And you will get, if you do this answer, if you do this on a calculator, you'll get a number that's quite a bit bigger than 2884. That's what you want. Because whenever you're doing these kind of problems, you always want to know, not necessarily even a ballpark figure. You don't have to know a ballpark figure, but you want to know whether your answer is going to be bigger or smaller than 2884.
Yeah.
And you know it's got to be bigger because we've got decay going on and it ended up at 2884.
Yeah.
And you will get a number, probably something on the order of 5,000 or so, using that. That's all you got for tonight? You sure?
Yeah, that's all my homework that I have.
Okay, I have no problem with that. That's fine. I never have any problem with that if you only have a half hour. Because usually my Wednesdays are pretty booked and tonight's no different. So I don't mind having a free half hour here for myself. Okay, Nick, let's see. We're going to do this time slot every week, right? From 4:30 to 5:30?
Yes.
Okay. Talk to you next Wednesday at 4:30.
Sounds good.
All right, bye-bye.